Let us move on to next kind of problems, that is we are using here Petrick's method to get the minimum sum of product solutions. Okay, earlier we had used K-maps and Quinn-McCluskey methods to get the minimum sum of product solutions. Here we are using one more technique called Petrick's method. So it is a technique for determining all minimum sum of product solution from a prime implicant chart. So to get the answers, first you have to be provided with the prime implicant chart. So this kind of chart we have seen in the Quinn-McCluskey method. The same kind of chart will be provided, okay, and you have to use the Petrick's method to find the minimum sum of products. As the number of variables increases, the number of prime implicants and complexity of the prime implicant chart may increase significantly. In such cases, a large amount of trial and error may be required to find the minimum solutions. So as you have seen in Quinn-McCluskey methods, we can solve problems which is of more than 5 variables. Okay, so you think that you want to solve the problem with 25 variables like this. Okay, so that time you cannot go for trial and error method, and you may be totally confusing how to solve those problems. So here we have one more solution called Petrick's method, where you can use it is a systematic way of finding all minimum solutions from a prime implicant chart than the method used previously. So here we have they will be providing you a prime implicant chart, so using that you can find the minimum solutions. Okay, so before we move on to the Petrick's method, we have to know what is the procedure in Petrick's method. So what you have to do here is reduce the prime implicant chart by eliminating the essential prime implicant rows and corresponding columns, and label the rows of reduced prime implicant chart as P1, P2, P3, etc. So you might have seen in the prime implicant chart left side you will be writing the prime implicants, is it? So there you have to mention before the prime implicants, you have to mention the numbers like P1, P2, P3 for each of the rows. Okay, that you have to do. Then form a logical function P which is true when all the columns are being covered. Okay, P consists of the product of some terms, each sum term having the form P1, P2, P1, sorry, P0, P1, P2, like this it goes on, where P1, P0, P1 represents the rows which cover the column I. So here what you have to do is, suppose you may have seen certain prime implicants has got mean terms, is it? Any prime implicant, if you consider, for example, a bar b, if you say, okay, it for example it may contain the mean terms 0 1, okay, and 0 2 may represent another prime implicant, maybe a bar c bar. So here in this case 0 is present in both of the terms, is it? You might have seen this kind of things in Quinn-McCluskey method. So you have to cover now both the or you say all mean terms you have to cover. So you have to then reduce the expression. So reduce P to a minimum sum of products by some multiplying out and applying x plus xy is equal to y. So this formula you have to remember in Petrick's method, that is x plus xy is equal to x. So in that way you have to reduce each of the terms. Each term in the result represents a solution, that is set of rows which covers all the mean terms in the table. So to determine the minimum solution, find those terms which contain a minimum number of variables. Each of these terms represent a solution with a number of minimum number of prime implicants. So that is in fifth step. Okay, after that you have to see for each terms found in step 5, count the number of literals in each prime implicant and find the total number of literals. Choose the term or terms with which correspond to the minimum total number of literals, and write out the corresponding sum of the prime implicant. So at last what you have to do is you make it minimum sum of product, or you say P is equal to something like P1, P2, P3, like this expressions you may be getting. So after getting that, you have to count the number of literals. Okay, I say P1, P2, P3. How many number of literals you have? 3. Okay, so compare that with other literals or other expressions which has got literals. Okay, so you have to count it how many number of literals, so which term has got minimum number of literals, that you have to choose. Okay, that will be written for the next step actually. Okay, so you have to count the number of literals in your problem. So let us take one problem. The example shown in the below table has two minimum solutions, that is f is equal to a bar b bar plus b c bar plus ac, or a bar c bar plus b bar c plus ab. So this problem we had solved in case of one example in Quinn-McCluskey method. So same problem we are going to take here to show the Petrick's method. Okay, so if you are seeing here particularly in that you have got a prime implicant chart, is it? So here a bar b bar a c bar b c b bar c b c bar a c a b, all these represents the prime implicants. Okay, so you know that so each of the prime implicants represents its own mean terms, 0 1 0 2, like this. Okay, so here you have to write in each of the prime implicants. For each of the prime implicant you have to write the numbers now, or representation. Okay, so what you have to write is p1 p2. So second prime implicant you are going to write this as p2, third one you are writing it as p3. So this is to mention, and these things will be written in the problems later. Okay, so for each prime implicant you have to represent by p. Okay, P4, P5, P6, like this. And 0, 1, 2, 5, 6, 7, all this represents the mean terms in your problem. Okay, and let us go for the problem. So as I said, what you have to do is you are going to label the rows, that is by P1, P2, P3, P4, P5 and P6. So we will be forming the logical function P, which is true when all the mean terms in the chart have been covered. Okay, so we are going to write an expression called P. P is equal to P1 plus P2, P1 plus P3, like this. Okay, we are going to write it. So P has to be true now. So let P1 be the logic variable which is true when prime implicants in the row P1 is included in the solution. Okay, P2 be the logical variable which is true when prime implicant in the row P2 is included in the solution, etc. So because column 0 has X in the, that is cross marks in the rows P1 and P2. Okay, P1 and P2, we must choose row P1 or P2 in order to cover mean term 0. So here, let me see, tell you here. See here, you are having 0 in first term, that is P1. Is it? In 0 in P2 also. So 0 is present in both of the rows. Is it? So you can choose either P1 or P2 to cover mean term 0. Is it? Any one you can choose. So, so what we write is, to cover that we are to cover mean term 0, I am going to write the expression as P1 plus P2. Understood? P1 plus P2. In order to cover mean term 1, so suppose I say I want to cover mean term 1. Mean term 1 is present in P1 and P3. So to cover mean term 1, what expression I can write? That is P1 plus P3. Is it? P1 plus P3. Similarly, to cover mean term 2, that is, sorry, where here it is. To cover mean term 2, what I can write is P2 plus, to cover mean term 2, I am going to write the expression as P2 plus P4. Why? Because in both of that P2 and P4 you find mean term 2. Okay, similarly, in order to cover 5, 6 and 7, the expressions will be written as P3 plus P5, P4 plus P6 and P5 plus P6. Okay, so this will be written. So what you can do is, it covers 0. Okay, so let us see, go on how to. So as I said, when you write for each of the mean terms, it has to be true. P1 plus P2 is true, P1 plus P3 is true, or P2 plus P4 is true. So what true means? It is equal to 1. So because we must cover all the mean terms, the following expressions has to be true. It must be true. And here you can see P, what you can write is P is equal to P1 plus P2, that is, to cover 0, we have written P1 plus P2, and to cover 1, what we write is P1 plus P3. To cover 2, mean term 2, we will be writing it as P2 plus P4. To cover the next term, we will be writing it as P3 plus P5. Then you have to cover 6, you will be writing P4 plus P6. To cover 7, you will be writing P5 plus P6. Is it? So I am going to write here, this is for 0, in term 0, this is for 1, this is for 2, this is for 5, this is for 6, this is for 7. So everything that is equal to true means it is equal to 1. The expression for P in effect means that we must choose row P1 or P2 and row P1 or P3 and row P2 or P4. So that expression P, what we write here, okay, maybe here you have written P1 for 0 mean term 0 representation, you have written P1 plus P2. That means for mean term 0, to cover mean term 0, you can either select P1 or P2. Okay, to select 2 mean term 2, you can either select P2 or P4. Is it? P2 or P4. So both cases you have to, like this. Okay, you have to write the expression. So the next step is to reduce P to minimum sum of products. This way, this is easy because there are no complements. So in earlier problems and all, when you are solving or when you are reducing the minimum expressions, you might have seen A can be written as A bar, A or A bar, like this. So you have to remember certain formulas to reduce it. So here there are no complements. Everything will be written in terms of P. Is it P1 into P2, P, okay, like this. So we first multiply out using the formula x plus y into x plus z equal to x plus yz, and the ordinary distributive law will be applied here to reduce the expression. So now you write the expression as, but after reducing, you might be writing the expression as P is equal to or you say P1 plus P2 P3 into P4 plus P2 into P6, P5 plus P3 into P6. Okay. So how did you write this? That is using the formula x plus y into x plus z is equal to x plus yz. So that means what we have written here is, so previously you had in the previous expression something like P is equal to P1 plus P2 into P1 plus P3, is it? And some other terms also you had. So let us take this particular thing now to solve. Okay, how we can apply this formula now? How we can apply, that is, we can write it as, so here P1 we can take it as X, okay, P2 we can take it as Y, and P1 here also can be written as X, plus P3 is Z, is it? So what we can write here after applying, that is a formula, that is X plus YZ you have to write now, is it? So what you can write, P1 plus P2 P3, so that can be written. So this same thing we have written over here, okay. So this is only for first expression we have written. Similarly, you can apply for the other terms as well. So what is the expression? That is P4 plus P2 P6 P5 plus P3 P6, like this we get. Okay, after this step, okay, after this step, what you have to do is, you have to again apply the distributive law, is it? So what you can do is P1 into P4, you can multiply there. Then P1 into P2 P6 you can do. So that is, you get P1 plus P1 P4 plus P1 P2 P6. This is a distributive law we have applied. Again, this thing can be multiplied, that is P2 P3 with P4 and P2 P3 into P2 P6. So then we get the next expression, and whatever is the last term you will write it as it is P5 plus, because you don't have multiplied here. Okay, I write it as it is. So after this step, I get one more term here. So here again we are going to apply the distributive law. So here what we will be doing here, see there, P1 P4 into P5, that you get as, when you multiply you will be getting it as P1 P4 P5, and next you have P1 P2 P6 with P5. When you multiply you get this second expression, that is P1 P2 P5 P6, and next expression is, you have to multiply P2 P3 P4 with P5, then you get P2 P3 P4 P5, and last term, that is P2 P3 P6 multiply with P5, you get this second last expression, and then again you have to go on multiplying the other terms. Multiply P1 P4 with P3 P6, then you get this next expression, that is P1 P3 P4 P6, and next thing is, you have to multiply P1 P2 P6 with P3 P6, then you get this expression, and P2 P3 P4 with P3 P6, you get the one more term, and the last term, that is P2 P3 P6 with P3 P6, so you get one more term. So this is done. So after this, we get one more kind of expression, that is P1 P4 P5 plus P1 P2 P5 P6, like this. Okay, one more term we have got. How did you get it? That is, we are going to use this expression, that is x plus xy is equal to x, to eliminate the redundant terms of from P. Okay, so this is applied to the, for this particular step, to get this particular step. That how we are going to apply is, take here, let us erase this. So let's do this particular problem. See here, something x. You take it p1, p4, p5 as x. Okay, p1 you don't find here. p1, p4 you don't find. Okay. So okay, read that. So write this term as it is, p1, p4, p5. Okay, and next term p1, p2, p5, p6 is written as it is, and then p1, p2, p3, p4, p5 will be also written as it is. So let us see there. P2, P3, P6. This term is written as it is. Now whatever is left out, you have to reduce using the formula x plus xy plus x. Okay. So here, if you see P1, P3, P4, P6 you have. Is it? So that is x. So here try to reduce that. So you get it as, if you do the particular problem, so you have take this term P2, P3, P5, P6. Okay, plus do with P1, P2, P3, P6. So if you take these two terms, P2, P3, P6, P2, P3, P6 you have. So if you see here the problem, you can see that P2, P3, P6 is common, P2, P3, P6 is common here, P2, P3, P6 is common. Is it in these three terms? So in that manner, if you are solving, what expression you have to get? That term you'll be writing here as that common term, whatever you have selected. Okay, that is P2, P3, P6. Okay, the left out terms you'll be writing here. So here, let us write that. So here, this is this term, same. This is this term, same term. And P1, P3, P4, P6. This is same. For rest, I have to apply the formula x plus xy equal to x. Okay, so here the terms which are common here is P2, P3, 6 among this term, among this, and here this, and here this. Okay, so what is x? X is this, and xy is, see here you have x term along with some y. Again here x term with some y, xy. Okay, here also xy you have. Here also xy you have. Is it xy term 3 times you have and 1 x you have. So that's why, what is that? X plus xy is equal to x. So that's why we write one single x, that is represented by P2, P3, P6. We got that answer now. Okay. So this is the expression, and now so we got the expression in the from the previous slide, that is P is equal to P1, P4, P5 plus P1, P2, P5, P6 plus P2, P3, P4, P5 plus P1, P2, P3, P4, P6 plus P2, P3, P6. So although there are 5 possible solutions here, 1, 2, 3, 4, 5, only 2 of these have the minimum number of rows. Okay, so you have to choose 2 out of this, because here P1, when you have written for P1 expression, it was including the mean terms 0 and 1, is it? P4, when we're taking, it included mean terms 2 and 6. So what is in the final expression, in the minimum expression, what you are going to write at last, it should cover all the mean terms. That is our final aim. So see through that which literals here it is going to give you the minimum expression. So which has minimum number of rows now here? This one is this, and this is. Okay, so here these two solutions with minimum number of prime implicants are obtained by choosing rows P1, P4, P5 and P2, P3, P6. So when you say this P1, P4, P5 or P2, P3, P6, it covers almost all the prime, mean terms, is it? All mean terms are covered by these two expressions, is it? So the first choice leads to f is equal to a bar b bar plus b c bar plus ac, and the second choice leads to f is equal to a bar c bar plus b bar c plus ab. So when you write what is that, P1, what is P1? P1 you have written earlier as a bar b bar in your table, if you are going to see. Okay, it was a bar b bar. Okay, same thing we are writing here. And what is P4? P4 is b c bar, is it? B c bar, same thing we got. What is P5? P5 is AC. Okay, and here if you are taking this expression, there are two possibilities. Another one, if you are taking, what is P2? P2 is A bar, C bar. What is P3? P3 is B bar, C. And what is P6? P6 is AB. So same like your Quinn-McCluskey method, there you have got two different solutions. In Petrick's method also you get two different solutions, which are two minimum solutions there. Okay.